Okay, guys, let's do trigonometry. Trig. Trigonometry is a branch in mathematics that deals with the study of triangles. Okay, we're studying the relationship between the sides of a triangle and its angles. Okay, the sides and the angles. So trigonometry was introduced to you in grade 10. You did it in grade 11, and you will do it in grade 12. It's one of the longest topics, which means it has a lot of marks. If you are good in your trigonometry, that means you'll be able to score a lot of marks. It's not a difficult topic. You can follow it as long as you know your rules. It's all about the rules. Some rules were introduced in grade 10, some in grade 11, and we'll introduce a few in grade 12. All right, so let's look at an overview of the things that you did in grade 11. So in grade 11, there were rules that were introduced and you used them to solve trigonometric problems. So this is my structure. It's something that I came up with, okay, so that you'll be able to follow the topic easily. Okay, it's something that I came up with. I like to structure my trigonometry like this. So in grade 12 or in grade 11, so in grade 11 what you did general trig. Okay, it includes it includes questions such as simplify. So you simplify a trigonometric problem, okay, using the rules, of course, the rules that were introduced in grade 11 and in grade 10. So you simplify, you calculate without the use of a calculator, and other. Okay, when I say other here, I'm speaking about those problems that cannot be grouped into these subtopics. Okay, so I say other. They'll be creative and create a trig problem, and you'll solve that problem using trig rules. Okay, other. Okay, you also did problems involving the aid of the diagram where you have to draw a triangle. So in aid of a diagram, you have two scenarios. Okay, they give you a ratio. When I speak about a ratio, when I say ratio, I'm speaking about sine, cos, tan, cotangent, secant. Those are trig ratios. Okay, they'll give you a ratio and an interval. A situation like this, let me make an example. They'll give you something like this. Tan theta is equals to 1 over 4, and then an interval maybe 180 greater 360. Okay, aid of a diagram. Okay, from this you'll be able, from this information, you'll be able to identify where you should draw your triangle, which quadrant you should draw your triangle. So aid of the diagram, you did this in grade 11. Another one, aid of the diagram, maybe they'll give you something like let's say tan 45, and they will equate it to a letter. They'll give you a letter or an alphabet, maybe K. They like K. And from this information, you will identify which quadrant is the right quadrant to draw your triangle, and you will answer the question. These are the things that you did in grade 11. We're just going through them. Okay. Okay, and then identities when you prove the left hand side, it's where you prove if the left hand side is equal to the right hand side, and we do this independently. We deal with the left hand side independently. We do not transpose. When we choose to deal with the left hand side, we deal with the left hand side. When we choose to deal with the right hand side, we deal with the right hand side independent. We do not transpose identities. Trig equation, there are two types of trig equations, where you are given an interval. Okay, when you are given an interval, that means the solution that you will find, it's specific to certain points. It's specific to certain point where you are given an interval. Okay, when you are not given an interval, okay, you're finding a general solution. It's the solution that's relevant to a lot of points, to many points. So you did trig equation in grade 11. And then 2D problems, sine rule, cosine rule, area rule was introduced. That's when you dealt with those figures, the triangles, and they'll give you a figure and you have to calculate maybe a side using these rules. And then there was trig graphs and functions. Trig graphs and functions. So these are the things that you did in grade 11. Okay, and you did them applying the rules that were discussed in grade 11 and in grade 10. So this is what you did. I like to look at my trigonometry like this. It's simple and it's easy to follow, and also when you studying, it will be easy to cover everything nicely, because you will cover general trig, aid of a diagram, identities, trig equations, 2D problems, 3D problems. It's really nice when you structure it like this. Okay, so in grade 12, there are a few rules that we're going to introduce. Okay, to be specific, there are two rules. That is compound angles and double angles. The structure is still the same as in grade 11. It's still the same. We're still going to do general trig, and we're going to apply the rules that we learn in grade 10 and grade 11. Okay, in addition to that, we'll add these two rules that I've just mentioned, which is compound angles and double angles. We're still doing almost the same thing, but with more rules. You're still going to do general trig, you're still going to do aid of a diagram, identities, trig equations. It's similar to that, to what you did in grade 11, but we're going to add more rules, which is compound angles and double angles. Okay, so we won't be doing 2D problems. We'll be doing 2D problems and 3D problems, and we will still apply the sine rule, the cosine rule, and the area rule, and also we will apply the two rules that we introduced in grade 12, which is compound angles and double angles. So we will be doing 3D problems, and we'll do trig graphs and functions. I hope this is clear. So we are doing basically the same thing, but with added rules. Okay, we're doing the same thing but with added rules. We're still going to follow this structure, this pattern. All right. Okay, so before we introduce these new concepts, let's do an overview of the rules that were introduced to you in grade 10 and in grade 11. Okay, definition and signs of ratios. Okay, for instance, let's say we are giving this point, okay, which is x is to y, and this point, let me draw a triangle, a nice triangle. Okay, and then on the x-axis from here to here I have x, and then on the vertically I have y. Okay, this is what I'm having. SOHCAHTOA. I know everyone is familiar with SOHCAHTOA. S stands for sine, O opposite, hypotenuse. So when we're using sine, it's opposite, hypotenuse. C stands for cos, and AH stands for adjacent hypotenuse. So when we're using the ratio cos, it's adjacent hypotenuse. T, it's tan, and it's opposite adjacent. So let's define these ratios. It's something that you did, but we just do a quick overview. All right, so sine theta, this is the triangle that we're using. Sine theta, I know it's opposite hypotenuse, which means it will be y all over. Here we have our radius. It is y all over r. It's opposites. Here we have theta. Sorry guys, we have theta here. Our angle theta. So it's opposite hypotenuse. And then cos theta, obviously it's adjacent hypotenuse, which is adjacent, in this case it's x, hypotenuse is, it's our r, our radius. Okay, tangent, tan theta is opposite adjacent. So opposite, it's y, adjacent is x. Okay, these are reciprocals. Okay, there's the reciprocal, and when we're doing the reciprocals, we just flip our ratio or our fraction. We flip our fraction, flip in this case, which means we will have r all over y here, Since we have x all over r, there we will have, here we'll have r all over x, and here we'll have x all over y. So these are our reciprocals. So these are our reciprocals. Okay, so I hope everything is clear, and this is something that you did in grade 10. All right, so what about the signs? So we know in quadrant 1 all ratios are positive, so we have a. Okay, we say a. And then in quadrant 2 only sign is positive, the rest of the ratios are negative. So s sign, here we have t, we have c. Okay, to remind yourself, to be able to remember this easily, people say SATC. Okay, so that's easier for them to remember that here on quadrant 2 sign, it's only sign that's positive. In quadrant 1 all ratios are positive. In quadrant 3 tan is positive. In quadrant 4 cos is positive. SATC. All right, so we must remember that if our angle, okay, our angle rotates counterclockwise or anti-clockwise, that means that angle is positive. Okay, counterclockwise or anti-clockwise, that means that angle is positive. But if our angle is negative, it will move clockwise like this. All right, that's very important. That's very important. Okay, let's speak about the initial side and the terminal side. Okay, our initial side, it's always on the positive x-axis. Our initial side is here. Initial side is here. Initial side. This is our initial side, and it's always on the positive x-axis, and it's stationary, it does not move. Okay, and then our terminal side, it's the arm that's moving. Okay, it's the arm that's moving. Okay, our terminal side. So in this case, let me just terminal side here. Terminal side. So I will have theta there. So the initial side and the terminal side, they form our angle. The initial side, it's the side that does not move, and it's on the positive x-axis. And the terminal side, it's the arm that's moving. It's the arm that is moving. So let's move on to coterminals. What are coterminals? Coterminals are angles that share the same initial side and the terminal side. They are not equal, but they share the same initial side and the terminal side. For instance, let's take 45. 45 degrees will be here. Okay, 45 degrees will be here. That's 45. 45 degrees will be here. So 45 degrees will share the same initial side and the terminal side to here. 405. So 45 and 405 are coterminals because they share the same initial side and the terminal side. They share the same initial side and the terminal side, so they are coterminals. All right. So let's look at another example. Let's say let me use maybe 100 and say 100 and 100 and let me use 135. So 135 from here to here. 135. And then let me use 495. 495 495. So 135 and 495 are coterminals because they share the same initial side and the terminal side. For me to see if 495 is a coterminal of 135. For me to see if 135 and 435 are coterminals, I can take 495 and just subtract 360. If I get 135, then that means they are coterminals. So coterminals are angles that share the same initial side and the terminal side. They are not necessarily equal, but they share the same initial side and the terminal side. I hope that's clear. All right, let's look at reduction formulae. So reduction formulae. So one of the important things about the reduction formulae that you must understand is that theta is an acute angle. Theta is an acute angle. So what do I mean by theta is an acute angle? An acute angle is an angle that's less than 90 degrees but greater than 0. It's an angle that's less than 90 degrees but greater than 0. So in quadrant 1, what do I have? I have theta. In quadrant 2, I have 180 minus theta, which means it's 180 minus an acute angle. Alright, so it's the angle that falls on quadrant 2. And then in quadrant 3, I have 180 plus 180 plus theta. And then in quadrant 4, I have 360 minus theta. So remember that theta is an acute angle. If I'm in quadrant 2, 180 minus an acute angle, that angle will fall on quadrant 2. It's in quadrant 2. 180 minus an acute angle will be in quadrant 2. Quadrant 3, 180 plus an acute angle. 180, we have 0 here, we have 90 here, we have 180 here, we have 270 here, also have 360 there. So if I'm saying quadrant 3 is 180 plus an acute angle, that angle will fall in quadrant 3 because 180 is here, 180 is here. It's an angle from here. Then I add an acute angle. That angle won't be more than 270. It will fall on quadrant 3. Okay, same as well as 360 minus an acute angle. That angle will fall on quadrant 4. So that's very important. It's very important to know the rules, and also not just to know the rules, but to also to understand your rules. Okay, so let's just do these very quickly. So sine 180, it's in quadrant 2. Okay, sine is positive in quadrant 2, so it's sine theta. Cos negative cos theta, because in quadrant 2 it's only sine that's positive. What about tan? Tan, it would be negative tan theta. Tan is negative in quadrant 2. It's only sine that's positive in quadrant 2. What about quadrant 3? Quadrant 3, I know that sine will be negative, cos will be negative, and tan will be positive. Tan will be positive. I'm using my reduction formulae. All right. So let's look at quadrant 4. Sine will be negative theta. I reduce this. When I reduce this, it will be positive cos theta, positive cos theta, and this one will be negative tan theta. So these are very important. Please don't forget them. These rules are very important. They will still help us in grade 12. Okay. Also, I would like you to note these. If you have sine negative theta, cos negative theta, tan negative theta. So sine is an odd function, which means it will be negative sine theta. And then cos, it's an even function, which means it will be positive. It will be cos theta. Tan is an odd function which will be negative theta. Alright, that's also very important, and all of these things that we're discussing now are things that you did in grade 11. Some of them you did them in grade 10. Alright, let's look at special angles. The instructions about special angles, that you must know these two triangles by heart. But that's time consuming, drawing a triangle and looking for ratio in a triangle. It's time consuming. So what we do, we use a calculator. Even when they say do not use a calculator, we do use a calculator, but low key. All right. So you will use your calculator, but you must be careful about these things. So if in your calculator you punch in a ratio of a certain angle, and then you get root 3 all over 3, you must write this as 1 all over root 3. You must not write root 3 all over 3, because if you write root 3 all over 3, the person who's marking for you will see that you used a calculator, because in these triangles, when you look in these triangles, there's no 3. Okay, there is no 3, so there's only 1 all over root 3. So when you get root 3 all over 3 in your calculator, make sure that you write 1 all over 3. When you get root 2 all over 2 in your calculator, make sure that you write 1 all over root 2. When you get root 3, you write root 3 all over 1 first, and then you simplify. And then when you get root 2, you write root 2 all over 1, and then you simplify. That's very important. Okay, so that's the person that's marking your paper. They won't be able to tell if you used a calculator or not. We use a calculator, but you use it low key. Let's look at cofunctions. Cofunctions they're also important. So cofunctions, they're like a reduction formulae, but with 90. Okay, they happen on quadrant 1. So if we can draw Cartesian coordinates, and we know here we have 0 and here we have 90. So if you say 90 minus an acute angle, it will fall on quadrant 1. 90 minus an acute angle will fall on quadrant 1. Okay, but there's a catch here. There's something that you to be very careful of. Okay, so so if you have sine into 90 minus a theta, so this is in quadrant 1, which means it will be positive. Okay, but the ratio will change to cos theta. All right, cos into 90 minus theta is in quadrant 1, which means it will be positive, because all ratios in quadrant 1, they are positive. Okay, but the ratio will change to sine theta. Okay, let's look at this one. Okay, sine into 90 plus theta. This is in quadrant 2, because it's 90 here, 90 plus an acute angle, which means it will go this side. From here it will go this side, but it won't be greater than 180. So it will fall on quadrant 2. All right, so quadrant 2. So it's in quadrant 2, and sine is positive on quadrant 2, but it will change to cos theta. Cos in quadrant 2. Okay, cos into 90 plus theta is in quadrant 2, but we know that cos is negative in quadrant 2. But since there's 90 there, it's a cofunction. That means here we'll have sine theta. Okay, so these are very important. We won't do tan. Why? Because if we have sine and if we have cos, we'll be able to solve the cofunction of tan without having any issues. We'll see this when we're doing the problems, when we attack problems. Okay, let's go to identities. So it's very important for you to remember that tan is equivalent to sine theta all over cos theta. Okay, tan theta is the equivalent, is equals to sine theta all over cos theta. This is equivalent, is equals to 1. You can also you can also use this as take cos, we transpose it to the right hand side. You will be left with sine squared theta is equals to 1 minus cos squared theta. Or you take sine, you transpose it to the right hand side, you will have cos squared theta is equals to 1 minus sine squared theta. Okay, these are very important, and these are the rules that you discussed in grade 10, some you discussed in grade 11, so they are still relevant in grade 12. They will help us in solving our trig problems. All right, okay, so let's move on to the next thing. All right, okay, so let's look at general trig. Okay, so we'll be following the structure. We'll be following the structure. Okay, with an exception that here we'll do 3D problems. With an exception that here we'll do 3D problems. All right. Okay. So general trig. So let's look at compound angles. So what are compound angles? It's something that's new to you that we'll be dealing with here in grade 12. So compound angles is when we adding two angles, or it's when we subtracting two angles. Okay, so compound angles is an angle. It's an angle formed by adding or subtracting two angles. For instance, we have angle A plus angle B, alpha minus beta, theta plus 60 degrees here, and x minus 70, etc. So it's when you're adding two angles, or it's when you're subtracting two angles. That's a compound angle. All right. Okay. All right. So we use the following identities to deal with our compound angles. All right. Okay, so your compound angles, they'll give you these your compound formulas of your compound formulae. They'll give you in a formula sheet during your test or your exams. But it's very important to know them by heart. It will help you. Okay, you'll be able to solve trig problems easily if you know them by heart, and also you save a lot of time if you know them by heart, because there will be no need for you to go and check and then come back, go and check and then come back. So if you know them by heart, it will be easy. Okay, so the first one is this one, which is this one. Sine into x plus y is equals to sine x cos y plus cos x sine y. The second one, which is this one, is sine into x minus y. We see that they are subtracting two angles within the brackets of this sine, within the brackets of this sine ratio. So it's equivalent to sine x times cos y minus cos x times sine y. So I like to say cos. I like to say to remember them easily. I like to say for sine is sine cos sine. Okay, if I have x here and if I have y here, I'll have x here, I'll have y here, x here, y here. And then if I have positive here, I'll also have positive here. It's cos, it's sine, cos, cos, sine. Sine, cos, cos, sine. Okay, sine, let's do the second one where we have separates. So I said we have sine, cos, cos, sine. Okay, this angle will come here, this angle here, this angle here, here, and it's negative, it will be negative. So that's how I remember them. That's how that's the technique that I use to remember them easily. So please practice these so that you'll know them by heart, and it will be easy. It will work in your favor if you know them by heart. All right. Okay, this is the compound angle for sine. All right. Okay, the compound angle for cos is cos, cos, sine, sine. All right. So it's cos x, cos y. It's positive, here it will be negative. Sine x, sine y. And then for this one, it will be cos, cos, cos x, cos y. It's negative, here it will be positive. Sine x, sine y. So these are the two new rules that this is the first one, the first rule, which is compound angles. The first rule introduced in grade 12. All right. So for cos, as you can see, for you to be able to remember them, to remember the formula easily, it's cos, cos, sine, sine, cos, cos, sine, sine, cos, cos, sine, sine. So it's, if I have cos, let me use a, b. So it will be cos, cos, sine, sine. And these angles go here. It's A, B, A, B. And if it's negative, here it will be positive. Let's look at the second one. A, which will be B. So I said cos, cos, sine, sine. Cos, cos, sine, sine. A, B, A, B. And then its positive will be negative. So it's very important that you know this by heart. It will help you. Okay, so this can be used to expand or contract certain trig expressions. So we can use the compound angles to expand and to contract our problems. That will help us to simplify or to solve our trig problems. Okay, let's look at example. I like examples because they make everything clear. All right. Example 1. Example 1, which is expand. Okay, tuanige. Expand the following and simplify if possible, and simplify if possible. Right, and then we have for A. A is sine x plus y. Then B, we have cos alpha plus 10. You see, we have cos x minus 60. And then D, we have sine 3x minus 45. All right, The question says expand the following and simplify if possible. All right, so solution. Okay, let's look at A, which is sine x plus y. So how do we expand this? We use our compound angle formula, which is the first one for. We'll use our compound angle formulae. Okay, and we must choose the right one. So since it's plus here, I will say it's sine x cos y plus cos x sine y. Okay, I used this one, the first one. I used this one. That's how I expand. I cannot I can't simplify this any further than this. This is where I stop. Okay, b it was cos into alpha plus 10. Okay, so it will be cos sine. So it's cos minus sine. I can't simplify this any further. Okay, this is the simplest step. Okay, I can't go any further. All right, see, cos x minus 60. All right, so it will be cos sine. So it's cos x cos 60 plus sine x sine 60. Okay, but I know I can calculate cos 60, so I'll have cos x into, if I punch this into my calculator, cos 60, I get 1/2, and then plus sine x sine 60, I get root 3 all over 2. So I can write this like cos x all over 2 plus root 3 sine x all over 2. So this is the simplest step. I can't go any further than this. Okay. Actually, I think I can. Yeah, I can simplify this. I can still do more. I can say since the denominators are the same, I can add the numerator, which is cos x plus root 3 sine x. Yeah, so it's like this. All right, then d I have sine into 3x minus 45. Okay, I can expand this into, I know it's sine cos sine, so it's sine 3x, it's cos 45 minus cos 3x sine 45. Okay, I'm using these formulas, it's just that I know them by heart, so it's easy if you know them by heart. All right, so cos 45 degrees is 1 roots. Let me write this like sine 3x, it's 1 all over root 2. Subtract cos 3x into sine 45 to my special angle. it's 1 all over root 2. So I can write this like this: sine 3x all over root 2. Okay, then here I can have cos 3x all over root 2. The denominators are equal, so I can add the numerator. The numerators will be sine 3x subtract cos 3x. So this is the simplest. This is as far as I can go. All right, then what's next? So was my first example. That's how we apply our compound angles. So let's look. Let's contract now. Let's contract. So contract. So example 2. Please take example 2 down. Write the following as a single trig ratio. So you've got to write this as a single ratio. The following as a single trig ratio. So in A we are given cos beta plus sine alpha sine beta. And then B we have sine x cos 40 plus cos x sine 40. And then C we have cos 2x sine 3x minus sine 2x cos 3x. Last one is D. We have cos 3a cos a minus sine a sine 3a. All right, so let's look at our solutions. So how do we contract that cos alpha cos beta plus sine alpha sine beta? So we'll apply our compound formulae. Okay, so I can see I have cos sine sine. I have this angle here, which is the same as this angle beta is the same as this angle, and I can see this is the compound angle for cos. So I can write this like this as cos into this angle, which is alpha. Since I have positive here, since this is cos, it will be negative, and then it's beta. So as simple as that. So this is my answer. All right, so let's look at B. B is we have sine x cos 40 plus cos x sine 40. So I can see I have sine cos, I have cos sine, and I have a compound angle similar to this thing. Right? And I can see that this angle here x is the same as this angle here. This angle here is the same as this angle here. So I can see this is similar to a sine compound angle. So I can use sine, and I use this angle here, which is x, positive because this is sine, and then 40. So this is how I contract this thing. Okay, this is how I contract this thing or reduce it. Okay, then the following one was C. Let's look at C. Cos 2x sine 3x minus sine 2x cos 3x. So when I'm looking at this one, okay, I know my compound angle. by heart, my compound formulae by heart. So it's easier for me to solve this. There's no need for me to always going back on my formula, and I look at my formula and I like, there's no need for me to be always going back to my formula and looking at my formula which one will help me. So I know them by heart. So as I'm looking at this one, I can see it's cos, it's sine, it's cos. Okay, so if I can rearrange this thing, it will be easier to solve it, because I know that there's a formula, there's a compound formula that can be similar to this thing. Okay, if I write it like this, if I just rearrange this to sine 3x cos 2x subtract cos 3x sine 2x, I just rearrange this thing. Okay, by rearranging it, it's easier to see which compound angle is it similar to. So from here I can clearly see it's sine cos cos sine, which means it's similar to the sines. Okay, and also I can see that this angle is the same as this angle is equal to this angle, which means I can say sine 3x, here it's negative, which it's negative here because it's sine 2x close, and then when I'm simplifying this I can say sine, and then here it will be x. So this is my answer. Okay, yeah, so far so good, we're just applying that the formulas. So this one is supposed to be, I'm just rearranging it. Okay, so cos 3a cos a subtracts sine 3a sine a. Now it's easy to see that this is a cos formula, compound formula. So it's cos 3a, since it's subtracts here it will be positive a close, that will be cos 5a. For a, what am I doing? For a, sorry guys, it's for a. So these are not complicated, these are simple. There's nothing complicated about this. We were just expanding and contracting using the formulae we introduced, compound angles. All right.